Hello, science enthusiasts. Welcome back. Today we're diving into a fundamental topic in chemistry, the differences between organic and inorganic materials. It's a fascinating world of carbon bonds, living organisms, minerals, and synthetics. Let's unravel the mystery behind these two categories. First, let's define our terms. Organic materials in the realm of chemistry are compounds primarily composed of carbon atoms connected to hydrogen atoms, forming what's known as carbon-hydrogen bonds. These compounds are often linked with life, as carbon is a fundamental building block of all living organisms. Now, shifting gears to inorganic materials, these ones lack carbon-hydrogen bonds. Instead, they are largely based on minerals or are synthetically produced. Organic materials are compounds that contain carbon-hydrogen bonds, often associated with living organisms. Inorganic materials, on the other hand, lack CH bonds and are typically mineral-based or synthetic. Organic materials are derived from living organisms, such as plants and animals. Picture the lush forest, teeming with life, or a bustling farm, filled with crops and livestock. These are the birthplaces of organic materials. Everything from the cotton in your shirt to the wood in your desk and the proteins in your meals come from these living sources. Inorganic materials, on the other hand, originate from non-living sources like minerals, metals, and synthetic compounds. Imagine the rocky terrain of a mountain or the stainless steel of your kitchen appliances. Carbon is a key player in organic materials. It's the maestro conducting the symphony of life, forming the backbone of organic compounds. Carbon atoms have the unique ability to bond with each other in long chains, creating a vast array of complex structures. They can form rings, branches, and even intricate three-dimensional networks. This incredible bonding versatility is the secret behind the diverse array of organic materials, from the DNA in our cells to the cellulose in plants. This versatility allows for the diversity of organic materials. Let's dive into some examples. When we talk about organic materials, we're referring to things like wood, which makes up the trees in our backyards, paper, the very substance of the books we read, wool, keeping us warm in our winter clothes, and even DNA, the blueprint of life itself. On the flip side, inorganic materials run the gamut from minerals such as quartz, sparkling in our jewelry, to metals like iron, forming the framework of our buildings, and synthetic substances like plastics. Organic materials often have lower melting points, are typically less dense, and can be more flammable due to their carbon content. This is why a wooden log burns easily and melts away quickly in a fire. On the flip side, let's consider inorganic materials. These are the tough guys of the materials world. They are often denser and have higher melting points. Think about metals. It takes a lot of heat to melt them down, and they're often less flammable. This is why your metal pot doesn't catch fire on the stove. So, there you have it, the essential differences between organic and inorganic materials, from their composition to their sources and physical properties. These distinctions are vital in the realms of chemistry and materials science. If you found this video informative, don't forget to give it a thumbs up and subscribe for more enlightening content from us. Thanks for joining us today.